Next, we're going to look at the factors that affect the rate of weathering. So, weather is a slow thing. Actually, most geologic processes are a slow thing, with the exception of earthquakes and landslides. Pretty much everything else happens slow. Tsunamis happen because of underwater landslides and earthquakes. So they're the result of something that happens fast. But for the most part, things happen slowly in geology, and weathering is no exception to this. So it takes a long time for it to break down. And there are conditions on the planet that will cause certain areas to either have slower or faster rates of weathering. So climate has a big impact. And remember, climate is a combination of weather and temperature, or moisture and temperature, the amount of water that's there and how warm it is. So we're going to look at both of those factors. So when we have areas that are in the tropicals, they're warm and they're moist, we get fast weathering that occurs in those areas. So the more water that we have, the faster the rate of weathering we're going to have. Water speeds up chemical reactions. It allows molecules to move around faster. It's a medium for a lot of chemical reactions to occur in, and that's why it increases chemical weathering. Not necessarily mechanical weathering, but it does experience the fastest rates of chemical weathering because it has the warmer temperatures, which also speed the rate of chemical reactions, and it has the more moisture. So the tropics are really good for that. So on the other side of things, if you're up in northern Canada, you're up in here, you're in Alaska, you're in northern Russia or northern China, you're in northern Eurasia, up in those areas where it's red, it's going to be really slow because it's cold, it doesn't get as much moisture up there, and so it's going to slow down the rate of chemical weathering that occurs. Now, in our cooler climates that have the freeze-thaw cycle, so this has to be an area where we actually get, where the temperatures get above freezing for part of the year. We need to have our warmer summers, not necessarily hot, but we need to have enough warmth that stuff melts, right? Because in order for frost wedging to happen, we have to have both sides of things. We have to have the warm time, we have to have rain that's happening in the summertime and spring. We have to have warmer temperatures so that the water can seep down into the rocks and into the ground and everything. And then we have to get down below freezing in the wintertime in order for the water to freeze and push apart the rocks in that area. So when we have an area where there's 4 seasons, we get a lot more mechanical weathering. Okay, we're talking about mechanical, that physical weathering. We get a lot more of that in areas where there's 4 seasons because it goes through that freeze-thaw cycle. So if it's cold all the time, that's not going to happen. So in cold areas, they're going to have slow rates of mechanical weathering and chemical weathering, right? In Antarctica, in the Arctic Circle area, all those areas are going to be really slow in both mechanical and physical weather or chemical weathering, which means that the rocks are going to stay the same way for a really long time. Now you're looking at it has to be moving water, or it has to be glaciers moving, or it has to be wind or something like that. That's breaking it down because these kind of processes aren't really happening very much. In our temperate regions, okay, which are in the United States, if you think about like the Great Plains, or across in New England, or going across the other way to Oregon, Washington, Northern California, those kind of areas. Now you've got your 4 seasons, so now you're going to have more mechanical weathering occurring in those areas. So we've got climate is the first thing that's going to affect our rate of weathering, right? How warm and cold it is, how much moisture there is. The next thing that's going to affect our rate of weathering is the kind of rock that we're looking at. So if you have really hard rocks, and you have rocks that don't have a lot of calcite in them, so you don't have a lot of limestone, if you have more granite, you have more of your intrusive igneous rocks, you've got more of your harder sandstones, things like that, that don't have a lot of calcite in them, they're not going to weather as quickly as something that is softer, a softer type rock, like limestone, that has calcite in it. So it depends on what the rock is and how closely those particles in the rock are packed together, so how tight the bonds are and how hard the rock is. So harder rocks, slower rates of weathering. Softer rocks is going to increase the rate of weathering. The surface area, so we've had climate, and now we've had the type of rock, and now we have surface area. Surface area is how much of the rock is exposed. So if you look in the picture, and I want you to think of a sugar cube, okay, versus grains of sugar. So this is like one giant sugar cube. And if you've just got one sugar cube and you take it and you put it into your glass of lemonade, then it's gonna dissolve slowly. Okay, it's gonna be there for a little while because the lemonade is going to have to dissolve away the outer layers and the outer layers and the outer layers until it gets to the middle. We're not stirring, right? We're just setting it in there. So it's going to take a lot longer because it has to eat away basically at all those layers, kind of like the rock here, right? It has to, whatever factors of weathering that are going on are going to only have the outside surface in order to deal with. But if the rock is broken down into lots of little pieces, now you have the surface area of each little piece of rock, and all those are exposed to all the agents that cause weathering. And so it's going to weather much faster if you have a large surface area. So this one here is showing a large surface area. This is like a spoonful of sugar now. I put a spoonful of sugar in, that's going to dissolve a lot faster because the lemonade now can dissolve each little grain of sugar individually, as opposed to having to deal with that big compressed chunk of sugar. It's the same thing with rocks. So when you have less surface area, it's going to slow down the rate of weathering. When you have more surface area showing, you have more of the rock that's exposed to the elements, and so you have a faster rate of weathering. So the greater the surface area, the faster the rate of weathering. All right, so our factors so far, we have had climate, the type of rock, and the surface area. And now we're going to look at topography. Topography is the lay of the land. It's where there are mountains and valleys and plains and streams and all that kind of stuff. And one component of topography is the slope that you're on. So the steeper your slope is, the more gravity is going to act on your rocks, and it's going to pull it downhill, which is going to pull apart the rock. So the steeper your slope, the faster your rate of weathering is, because it's going to pull down top layers and expose the bottom layer. So it's going to increase your surface area by pulling down layers of rock because gravity is acting on it. So steeper slopes will be faster rates of weathering. Flatter slopes, less weathering. So we talked about water and temperature, right, which was part of our climate. We talked about surface area. We talked about our rock types. And we talked about topography. We're going to add climate into that. So our climate, remember, is water and temperature. All right, that ends this section. So once again, you're going to, we're going to turn off this video, you're going to go to your next page, and once again, you're going to have another Check for Understanding quiz. It's the same as the last one. You're allowed to take it as many times as you need to get that 100% in order to go on.